Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quad University of Science and Technology. Today we will take lecture number 8 of the subject of Object-Oriented Analysis and Design, in which we are going to discuss software development process models. And the subtopic is the Rational Unified Process Model. Dear students, a rational unified process model is an important process model which is incorporated in object-oriented analysis and design. This process model is based on UML concepts. Hence, this process model is very much important for designing the software which is based on object-oriented analysis and design concepts. This is the discussion agenda. It contains the topics of the rational unified process models. Then we have the diagrammatical representation of the rational unified process models, where we will discuss different phases of the rational unified process models. And then we have the application of rational unified process models. And at the end, we will present you some advantages and disadvantages of the rational unified process model. Now, what is the rational unified process model? Basically, the rational unified process model is a process model which is proposed by rational corporations of the IBM. The IBM is the early contributor of the unified process models, and rational unified process model is based on a certain environment which takes help from the tools and technologies which supports the process. So rational unified process models is completely specific to certain environment which is utilizing certain tools and technologies for development of the high level software products. So these tools and technologies helps to develop the high quality code as well as high quality design as well. Now, rational unified process model is the example of a modern software process model which is in fact derived from a work based on UML. So UML is in fact unified modeling language which is used as a tool for software designing and analysis. So first the problem is analyzed and then the problem is designed, and later on the UML enable us to convert the design into the code as well. So in UML we create a certain patterns which are very much abstract but also very much concise, and the UML help us to kill the complexity issues as well. Now, rational unified process model is a hybrid process model. The hybrid process model means that it also brings us to create a generic models of the softwares, but also it helps us to support and illustrates the good practices in the specification of the designs and also in the specification of the requirements. So unified process model help us to specify the requirements of the products, and also it helps us to create a meaningful designs which will later be converted into the practical code. So from the designs we create direct code as well, and that code must be free of different faults and errors. So rational unified process models is a conventional process model, but it presents a single view of the process as well. Next is the rational unified process model phases. There are 5 phases in rational unified process model. First one is called inception phase. The second one is the elaboration phase. The third one is the construction phase. The fourth one is the transition phase. And the last one is the production phase. Now we will examine all these 5 phases in detail. First one is called the inception phase. In the inception phase, the business goal or the business case of the system is incepted. So in the inception case, we will identify that what are the cost benefit analysis of the product. So here we will identify different benefits of the product as well as their cost as well. If the costs are larger than the benefits, then the project will be cancelled. But if the benefits are more than the cost, then we will create the project. So the inception phase is enable us to establish a business case for the system. Here we will identify all the external entities including the people and the systems. People are those users or actors which will interact with the system. And also the systems includes different sorts of the components which will make the whole system. And all these entities including people and system should be identified in the inception phase, and also their interaction towards the systems should also be identified. Then we will use this information to assess the contribution that the system makes to the business. Means that what is the business value of the system? As I explained earlier, that here we will create or calculate the cost benefit analysis of the system. If the costs are more than the benefits, then we will cancel the project. But if the benefits are more than the cost, then we will develop the project. So in this contribution, if this contribution is minor, means that if the value of the inception phase is not more, that means that it is minor, then the project may be cancelled after this phase as well. Now remember that this phase is usually conducted for that project which is general purpose market product. For the specific purpose market products, already the inception phase will be in fact carried out, and based on that inception phase, then the customers will decide that whether to develop the project or not. After the inception phase, the next phase is the elaboration phase. The basic purpose of the elaboration phase is to elaborate or to develop the understanding of the problem domain. Now remember that there may be many domains of the problems. For example, if it is the Android domain, or if there is the database domains or artificial intelligence domains or the network domain. So there may be different domains of the problem. Also, after identifying the domain, the purpose of elaboration phase is to establish an architectural framework for the system. In the architectural frameworks, we will identify different components of the system. Also, we will define different quality attributes which will be achieved through the architecture frameworks of the system. Now, elaboration phase also helps us to develop the project plan and also to identify the key project risk. The project plan is an important activity of the project manager. Usually the plan helps us to complete the project, and that will be drawn before or prior to the project. And also elaboration helps us to identify the project risk. The risks are different factors which can affect the quality, cost or the schedule of the project. If these risks are very much catastrophic, then it can affect the project. If these risks are not serious, then we will ignore all these risks and we will continue the development. After completion of this phase, we have the requirement model of the system. In the requirement model of system, we have the use case diagrams which will help us to specify the problem. The use case diagrams are in fact the diagram where the user will interact with different scenarios of the system, and the scenarios are in fact the functionalities of the system. Also, after the elaboration phase, we have an architectural description and the development plan for the software. The architecture description contains different components of the system and also their interaction with each other. The architecture defines the quality attributes as well. And at the end, we have the development plan of the systems, that how we will develop the project, which components include in the project, and what kinds of technologies will be utilized to develop the project. By the technology, we mean that different software development languages like C Sharp, Java, etc. used for the software development. The next phase is the construction phase. As its name indicates, in this phase, the system designs, programming, and testing is performed. So, first of all, the system is designed. The designing is developed in the UML. After designing, the system programming is performed. The programming will be computed using different programming languages like C++, Java, C Sharp, etc. And at the end, we have the testing of the system. Here we will conduct different sort of testing. For example, unit testing, integration testing, system testing, and all other testings in which we will test the quality of the system. So here the system is developed into multiple modules, and all these modules are developed in parallel and then integrated during with each other in this phase. So all the modules are developed and then they are integrated with each other to form the final software products. On the completion of this phase, we have a working software system which will be have an associated documentation as well. And then the system will be ready to be delivered to the end users. So after this phase, the complete product is in fact created and we have a working final products here. And also with each and every functionality we have associated documentation, and the documentation will be used as a manual for the usage of the softwares. So the software will be completed here and it will be ready for the end user to be used by that particular user for the functionalities. The fourth phase is the transition phase of the rational unified process model. In this phase, which is mostly the final phase in many rational unified process models, it is concerned with the moving the system from the development community to the end users community and making in a such suitable format that it will be ready to work in the user environment. This is also sometimes ignored, but in most software process models, it is a fact that it is very much expensive and sometimes problematic activities. In the transition phase, we actually install the software at the end user environment. After completing this phase, we have a documented software system that is work correctly in the operational environment of the end users. So basically, the purpose of the transition phase is to install or launch the software on the end user environment. By the end user operational environment, we means different hardware and software environments on which the system will be used. So this phase is very much important. This is also in fact a phase where we will install or deliver the product to the market. For the general purpose market products, we just deliver the product. In the transition phase, we will install or we will deploy the project on the user environment. The final phase is the production phase of the rational unified process model. The production phase of the rational unified process models is in fact the phase where the system will be monitored and maintained after installing the product on the user environment. The production phase of the unified process models is the same as like the deployment phase of the generic process. But for the specific user products, the production phase is in fact a phase which is used as a monitoring the products for certain defects, and also it supports the operational environment as a infrastructures, and also it helps us to defect reports and request for changes as submitted and evaluated by the customers. So the purpose of the production phase is very much important for us because this gives us a feedback from the customers, and also it gives the honor of business to the development organization. So basically the production phase is used to monitor the product and also monitor the different sort of the defects and errors that are submitted by the end users for the correction. Now this is a generic diagram of rational unified process models. So first we have here the inception phase, then we have the elaboration phase, then we have the construction, transition, and final one is the production phase. Now inception phase is in fact created from the communications and planning. Basically, the purpose of inception phase is to provide a meaningful communication between different stakeholders and also to create the planning of the software development. The communication is in fact a certain medium which will be used as to transfer the information from the one stakeholder to another stakeholders. The stakeholders will be those people which will be involved in the software development, and also will be those people which will be involved in overall software development process model. For example, the customer is also one of the stakeholders. Similarly, the business analyst is another stakeholder. Similarly, designer, developers and testers and project manager are also one of the stakeholders here. So these stakeholders are actively involved in the communication system so that they can transfer information between each other. And also the planning of the softwares is created here. The planning will be in fact a document which will contain different guidelines, and also it contains different scheduling as well as the risk management strategies as well. The planning also contains the cost business analysis and also different budgets that will be used for software developments. Next phase in the rational unified process model is the elaboration phase. The elaboration phase is in fact created from the planning as well as modeling. In the elaboration phase, we create the project architectures, and that project architecture will be the combination of different components which will interact with each other, and also the architecture defines the quality attributes here. After the modeling, which means that the model will be the architecture model, we will in fact perform here the construction. In the construction phase, we will practically develop the project using certain tools and technologies. After the construction phase, we have practical products here, and then the software will be deployed on the user environment, and that is called the transition phase. In the transition phase, we will practically install or deploy the project on the user environment so that the user can use that products. After the deployment, if there are any sort of the errors or problems, then we will maintain these errors and we will correct these problems, and that is the production phase here. In the production phase, we will in fact observe the system so that if there is certain problems, then we will resolve these problems, and that is the final phase of rational unified process model. This is the another diagrammatical representation of the rational unified process model. You can see that there are four phases in the rational unified process model: inception, elaboration, construction, and transition, where there is no production phase here. The production phase is not necessary because the production phase is the maintenance phase, so that is obvious that in the transition phase, if there are any certain problems or defects, then we will maintain that particular defects here. First of all, here you can see that it is in I1, that is inception 1, that is elaboration 1 and elaboration 2. We have multiple construction 1, construction 2, construction 3 and construction 4. Also, we have transition 1 and transition 2. So that means that we can divide each and every for these different phases into multiple parts as well. It depends on the size of the project. If the size of the project is larger, then we have multiple construction here, means that multiple units will be developed here. And there will be multiple transition. It means that there will be multiple prototypes of the softwares. Now, in the first of all, we will create the business modeling of the system. Here you can see that the business modeling is carried out throughout the phases of the rational unified process model, but it is mostly in the inception and in the elaboration phase. Means that here we will create the business model of the system, means that here we will create the cost benefit analysis of the system. Next one is the requirement phase. You can see that requirement is in fact here mostly occurring in the elaboration phase. That means that here we will provide the requirements of the systems, that is requirements of the user in the form of the use case diagrams here, which is the part of the elaboration phase. Next one is the analysis and design. You can see that analysis of designs are also in fact incorporated in the elaboration phase here, and mostly you can see that this is in the elaboration phase, and in the implementation is mostly conducted here in the construction phase. You can see that the bar of the implementation is mostly occurring in the construction phase, where we will practically develop the softwares. And then we have the testing phase. You can see that the testing phase is in fact carried out in the elaboration, construction and in the transition phase. Mostly this will be in fact in the construction phase here. You can see that when we will develop the software, then we will develop the unit as well. So because the system is developed here in the unit by unit, then we will test the system as well. And at the end we have the deployment phase. The deployment phase means that we will practically provide the product into the end user environment. And you can see that this is occurring mostly in the top of the transition phase here. You can see that the bar or the graph is mostly occurring in the transition phase here. Now with respect to the time, we will complete all these activities from starting from the inception and until the transition phase here. Now, there are 6 fundamental practices of the rational unified process models. By the practices here, we mean that where we can use the rational unified process model, means that there are multiple scenarios where we will utilize the rational unified process model. Here, the first practice is to develop the software iteratively. So, rational unified process model help us to develop the software iteratively. Means that it helps us to tackle the high risk elements on every stage of the project, and then we increase the understanding of the problems, and then at the end we will make a useful changes until we reach to the solution of the problem. So it gives us iterative enhancement of the software development as well. The rational unified process model also helps us to manage the requirements. By managing the requirements, we mean that the system will be developed in certain ways that all the user requirements will be managed. And the management of the requirement is done through the development of the use case diagrams, which gives us the user scenarios of using the system. In the use case diagram, the system will enable us to draw this user interaction with the system. So the managing the requirement describes the full organizing of the requirements, and also to keep track of the functional requirements, the documentation, the trade-off between different requirements, and also the decision and the business needs here. The trade-off means that when we say that one requirements and there is in fact the choice between two or more than two requirements, then we will identify the trade-off. Means that if this requirements is much more important than the another requirements, first we will develop that particular requirements there. Similarly, the rational unified process model also help us to use the component based architectures here. Here, the component-based architecture will be created, means that different components will be analyzed and identified, and then these components will be integrated with each other, and also the interaction of the components will be provided. So this helps us to structure the system architecture into multiple components, and these components will be later reusable as well, means that we can also reuse the existing components in our system as well. So these components will not only reusable but also at hand in the future project these components can be used here. Another important practice of the rational unified process model is that it gives us visual representation of the software model, and that is provided through the UML. It gives us how to create a visual model of the software systems in which different structures or components will be arranged, and the behavior of the architecture and components as well. The behavior means that the functionality of the different components in the software architecture are provided through the visual representation methods. Because UML is the visual representations, so that's why it gives us more understandability of the problem. Another important fundamental practice of the rational unified process model is to verify the software quality. Because we are creating the architecture of the software in the rational unified process model, so that's why we will verify each and every quality attributes here. There will be multiple quality attributes such as the understandability, usability, portability, efficiency, etc. Similarly, security is also one of the important quality attributes. So, verifying the software quality will help us to evaluate the control of the quality of all the activities during the software development. Similarly, the rational unified process model also helps us to control the changes to the software. The final phases of the software are responsible for the maintenance, which is the production phase. Here, we will take important feedback from the customers, and also we will record any sort of the changes required in the software. So it gives us the ability to control the track and monitor the changes which enable us to constantly and successful development of the software. So it gives us a secure workspace by isolating it from the changes. In turns brings us our teams together, making them work as a unit here as well. So rational unified process model helps the team to become one big team, and that will help to develop the software as a unit. Now these are different building blocks of the rational unified process models. The building blocks contain different people and artifacts which will in fact be used as a development of the product. The development of a product will be in fact carried out through the rational unified process model. The first one, the building blocks of the rational unified process model is the workers. The workers is provided through the woo components here. So here the worker contains the people who will develop the product. So it contains different behavior and responsibility of all the individual team members or the group of all the individual members which will act as a team here, and they are working on activity in order to produce the final products. Another building blocks are the activities which is defined through the how. The activities are multiple tasks which will be carried out while developing the product. So it contains a unit of work that worker is to perform. So basically activities have a clear purpose of typically by creating and or updating the artifacts here. And next one is the artifacts, which is the word components here. The word building blocks provides us the what sort of the artifacts that we are going to develop. Basically, the what defines the tangible output which is emerges from the process here, and the process is the rational unified process model, where new codes to added to the additional lifecycle models will also be created. And the final one is the workflows, that is the when. You can understand that the when means that here then all the activities will be completed, and it represents a diagrammed sequence of activities in order to produce the observable values and the artifacts, and that artifacts are the observable products will be in effect completed when a complete time span is produced here. Now, there are certain advantages of rational unified process model. The rational unified process model put us on emphasis on addressing very early high risk areas. Means that we can identify the high risk early in the software process model. Basically, it doesn't assume a fixed set of firm requirements at the inception of the project, but also it allows us to refine the requirements as the project evolves. Means that the refinements will be continued until the project is completed. It doesn't put either a strong focus on the documentation or the ceremonies. Means that there will be no certain high-level documentation here in the rational unified process model. So all the energy will be in fact consumed on the product's development here. The main focus remains on the software product itself and its quality. So in the rational unified process model, our main focus is on the quality, because in the rational unified process model, we create the products in terms of its architecture, and the main achievement in architecture is the quality. Now, there are also certain disadvantages of the rational unified process model. The first disadvantage is that the rational unified process model is not considered as a particularly agile. Means that it is not an agile process model where we frequently or we actively perform the development. So here the recent studies shown that adopting the another version of the rational unified process model, we can get agile quality of the rational unified process model as well. It also fails to provide any clear implementation guidelines. There is in this process model we have no clear implementation guidelines. Although it gives us the architecture values, but it doesn't give us the complete guidelines about the software development. Rational unified process model leaves the tailoring to the user entirely. Means that here it depends on the user as entirely. So here the user is actively involved here, but it it is in fact completely depending on the user here as well. Now, dear student, this is the end of this lectures. Here are two different references of the software engineering books where you can study this process models. The first book is Software Engineering Best Practices, lesson from the successful projects in the top companies, and it is in fact Keppers McGraw-Hill 2009 book. And the second one is the Software Engineering Einsatzwahl Practices Hall 2010 books. So you can study these two books for more detail here. Also, if you have more questions, you can ask this question through the email. My email is m.kadim@kust.edu.pk. You can see this email address at the footer section of these slides. And I will wait for your question and I will respond you immediately as soon as I get your questions. Thank you very much.